Again, to Mastic Radio Control Submarine Base. This is Sub-Ed, again, down in the Individual Anemics Electric Model Boat Division, also known as the Mad Lab, where today I'm going to give you a very brief overview of how I converted my Robbe F-14 from 75 megahertz to 2.4 gigahertz using the Corona 2.4 gigahertz do-it-yourself radio control system. It's available at Hobby King. I ordered it. It took about, 3 or 4 weeks to come, and it wasn't all that expensive. I think it was $50 or so. But I decided now, with everything going over to 2.4 gigahertz, that I was going to go ahead and convert at least the models that run at periscope depth to 2.4 gigahertz. I'm not going to sit here. I'm not going to discuss the merits of one over the other. But it's my understanding that the new 2.4 gigahertz is, in terms of radio glitching and loss of signal, is a little bit more stable than 75 megahertz. I will be finding that out, of course, in the future. The only problem is you have to run at periscope depth, where this very short antenna must extend above the water, because the 75 megahertz can penetrate the water, where we've always been fortunate in the Northeast to get down to about 30 feet, 10 or 5 feet in the pool, depending on the chlorination. But an old subsailor way back, Mike Dory, ran on the West Coast where it was brackish, and he was forced to run at periscope depth all the time. Again, not the merits, but I honestly prefer, unless I'm in a pool, to run at periscope depth. I hate losing sight of my model unless it's close to board. So I've always essentially been stuck at periscope depth, so this works for me. And if it lessens glitching and loss of signal issues other than wave crashing over the scope or heading a little too deep, this is going to work perfect for me. So I made that decision. Again, you do this at your own risk, and unless you're comfortable with soldering electronic components and working with RG178 cable, which is a very, very fine cable, and it's quite easy to burn through the insulation between the outer conductor and the inner conductor. Maybe you can have a friend or an expert who does this for you and have them do it for you. But I did find it easy. I'm a printed circuit board designer by trade. But believe it or not, I don't really do a lot of soldering myself. So I found this within my capabilities. So let's just go for it. Again, this is your Robbe F-14. It was 75 megahertz, which is no longer, I don't even believe, available at all, much less in 75 megahertz. If you can find one, they are, in my mind, the perfect submarine radio. I get the use of all 8 channels now, which is more than enough, of course, for rudder, fair water, or bow planes. I have either a single engine, this would be my, or dual throttle control, depending on the subtype. If it's single prop, I have the stern planes here. If it's a dual prop, I will have both individual props, and I will control my stern planes here with that proportional. I have the dive and a blow switch. I have a selector switch here, turn lights on, whatever, and this will be hooked up to my gas blow. I'm using a pump displacement system using the T-valve that Skip introduced many years ago in his albacore, so I can surface and submerge the boat using a pump. But if I get in trouble, I can push this little red button. It'll hit a solenoid, use the gas to get the boat up to the surface. That's what's nice about that system. And also, if it's loss of signal, it'll blow and return the model as well. But enough of that. That's why I really love this radio. When I turn the radio on, you now see a red light here, and that is a light indicating that it is now running in 2.4 gigahertz mode. That is where I ended up installing one small board. This is the board that the red light indicates is power, as well as this power, but also indicates connection and linking up to the receiver, which is done in a separate set. And there is the small receiver switch that you press. I removed the backing of this trim adjustment, which is unused on this model, and I found it a perfect place to install that particular circuit board. So I'm going to turn that off, and let's open this up, go through a quick overview of how easy it is to do this. Another nice thing about this Robbe unit, it is so easy to work on and to customize. It just really is. It's such a nice transmitter. You know, so let's show you exactly how the modification board. When you purchase the Corona 2.4 gigahertz do-it-yourself radio control system, you get this board, which is attached to this board here. Okay, this small board here may be difficult to see from the lighting, but this large board here is attached to this small board here, which I installed using some stock in that aforementioned trim well. It fit perfect there, and I used some stock and a little CA to install it there. It's nice and steady. For this large board, which happens to have a metal heatsink on the far side, I installed some 2/4 inch pieces of PVC stock. Use a little CA to mount that down below, and then double-sided tape, and that sits right here. What you have to solder to this is this small antenna connection here, and that antenna connection comes up to this point here, where you have to enlarge a hole to fit the new 2.4 gigahertz antenna. So basically, some stock to mount this here. The wires are all soldered. Then you have to solder, per the instructions, the antenna coax to the motherboard, and the daughter card, we'll call this the motherboard. That's the daughter card installed there, and the connector from the daughter card, from the motherboard, comes up through here. It's a 3-pin connector, and you will install that in the trainer port. Let's see if I can get something to point at that. You will install that on the trainer port right here. Let's see if I could show that. So you could see this is the wire here coming into the trainer port. The first lead, we'll call this the outboard end. The first lead is ground. The second lead is the +5. The third lead is the signal. And you will notice that the trainer port has 4 connectors. You're using the first 3 counting from this end of the board. Okay? This is the same end where all your servos go. If you're familiar with this, you'll have no problem. So you black to the first, red +5 to the second, black being ground, +5, and the signal being the third. The fourth, which is all the way outboard here, you leave unconnected. And you can use a standard Futaba connector like that and just mount it to it, solder it to it. And then you'll notice too, you can get a connector online that's specifically made. Hanson Hobbies, I believe, has them. I didn't know about it at the time, so I used the standard Futaba connector, and that fits quite well right on the first 3 pins. Remember, the outmost pin is your ground power signal. Okay, I mentioned that several times. It's that easy. The only other thing you have to do is, you will notice 2 jumpers here by this capacitor. Okay, you cut and bend up the outboard jumper. Okay, there's actually 3. There's a small one that's all the way outboard, but of the second 2, you want the first of the second 2, so it would be actually the first of the larger. So if you can see there, you cut, lift them up. You can always bend them back in place and solder it, disconnect this, and you now have your 75 megahertz back. What I did with the connector, the antenna connector, I just covered it in tape, put it over here. So in all of 5 minutes of pulling this out, reconnecting the old antenna, and putting a little solder gap there, I'm back to my old channel 78. I didn't even remove the crystal. It's that easy. So the most time that took this was actually understanding how I wanted to arrange it. Once I realized that this trim well was perfect to mount the indicator light and the assignment button, it all fell in fairly easy. So that was it. That was all the work that was done on the transmitter side. Again, the motherboard mounted with 2/4 inch pieces of PVC that were CA'd to the inside, and then used a piece of double-sided tape, so that's even removable. This board was attached with CA using small pieces of 1/8 inch stock to mount it properly. And again, the connector coming up from the motherboard that supplies ground, power, and signal. Again, first lead, ground, second power, third signal. And this jumper is cut, and you're in. I mean, it took, the longest time was figuring out exactly how I wanted to lay it out. And I have all 8 channels operational. That's nice. Some of you may use the multicoder. I'm not sure. I have the multicoder. I put it aside for now. Don't know if I'll ever use it. I don't really need that many channels. Let's go on to the receiver. Okay. Again, fairly robust. It's nice. I really, really enjoy this system. Okay. That's it. Powered up. I have my indicator light that, of course, I didn't do anything screwy. I have almost 100% power. Put it down. Let's show the modification that needed to be done to the receiver. Dave Merriman, he's an excellent sub driver himself. RC guy, goes back many years. He needs no introduction. And he has an excellent article on how this is done. And you can find that at the link down below. It's the sub forum for the subdriver site. The link's again down below, and I suggest you study that in detail. I'm just showing you how to do it on the Corona do-it-yourself system. That was the CTZ8 that was installed. That's the transmitter. We're now going to look at the CR8D, which is the receiver. This thing costs 15, 16 to 18 bucks, depending where you go. And considering a 75 megahertz receiver is 70 bucks, I'm quite happy with this. In order to get it apart, you need to push these little indexing tabs in, because when you get this, it comes with the standard antenna, and you have to do a little rework in order to make it a submarine antenna. And that's again why I mentioned Dave's article before, because he goes into the whole reasoning why you need a coax, because you need to get this up through a periscope to be able to be above the water. So of course they can link up. And here's the receiver. It comes with 2 antennas. I removed both. You solder the center conductor, and these pads are identical on either side, to the single pad, and the ground, the braid, you solder to the larger pads on the outside. I did that, and after I did that, and I verified, I tested it, I then covered it with JB Coldwell to make a better mechanical. Such a flimsy connection. If you're looking at this, you could see the dimensions that you're working with. And you're going to want to get yourself a decent soldering station to work with it. I have a Weller WES51 that I picked up for $78, and it's the complete station. You can do almost anything in our hobby with this, and you can set the temperature. Let me just show you. I really think if you're in this hobby, you should spend the money to get one of these. Again, it's the Weller WES51. I highly recommend a real soldering. Comes with 3 tips. Actually, it came with 1. I bought 3 tips extra. I'm going to send a link out to where I purchased it, but they go about 120 bucks. I found it for 78 somewhere if you look for them. You can dial in the temperature depending on what you're working on, and you'll be able to achieve decent results with the smaller tips and the finer temperatures, so you're not lifting vias or anything on the circuit board. But basically that was it. I trimmed all of this using a razor blade. There is a tool you could purchase. I did purchase the tool. I don't know where I placed it right now. It's around in my junk pile somewhere. But again, I had to. The details of doing this is on David's website. Actually, it's David's article, and I'm just showing you that I did it with a CR8D receiver, and it works. It works. So there are different do-it-yourself kits out there. This, again, to wrap this up, is a Corona 2.4 gigahertz do-it-yourself radio control system installed in a Robbe F-14. Really fun stuff. Really fun stuff we got going out here nowadays, guys. And again, you all out there have a great day, and may all your surfaces equal your dives. Bye now.